Hello, hi to everyone. Welcome to chapter number 3 DC power supply lecture number 1. So in this particular video we are going to discuss about the introduction as well as regulated unregulated power supply, study and pulsating DC voltages. So let us see the introduction now. Okay, DC power supply. In case of practically we are using the DC power supply for batteries. The batteries we have a as so dry cells. So these are the sources we have, but the disadvantage of these particular sources are every time we can replace these particular batteries or dry cells. So it is also maintenance is required, this particular batteries or dry cells. So we have to overcome all these problems. We are introducing the particular AC supply is converted to DC. We can use it as a DC power supply. Got my point? So in that particular case, for example, I'm taking the some AC supply with help of the rectifiers. I'm going to convert this particular AC supply into DC supply. So when I'm using this rectifier, some pulses, this pulsating, that is ripple factor is present. That's why you're using filters to rectify that ripples. After that, we'll get some DC, but the DC will be value will be always you are maintaining constant DC. We are using as a regulators, right? So this is about all about the DC power supply what we are using. So now all of you got my point. Why are using DC power supply? In case of DC power supplies, generating sources are the batteries or dry cells. We have a DC power supply sources. So those are maintenance is more, and also it is not possible to required value by adjusting the small variations. Batteries and dry cells are fixed voltage sources. That's why we are moving to the this particular regulators. So first one, regulated power supply, unregulated power supply. Unregulated power supply means if load resistance increases, the value of current drawn from the circuit also changes. Okay, that means the voltage applied available at the terminals will be reduced. That means that you want to maintain the regulated power supply constant voltage at the output, but whenever you're using more load or variable resistor, that means that load is increases in the output side, automatically the current and voltage values are changes. This particular supply call it as a unregulated power supply. Okay, voltage value as well as current value both are changes. That's why it is called as a unregulated power supply. Next we are moving to the regulated power supply. So regulated power supply now we are using. In case of regulated power supply, the input is AC, right? The input is AC, it is connected to. So these are the what we discussed in the introduction. All these equipments are present here or not? Yes. So the equipments are first of all we are connected the input supply to the transformer, right? What transformer is doing? The transformer is step up or step down voltage for required value. So first of all transformer is the first one. So it is doing step up or step down voltage to the required level. So that is the first one. After this particular transformer step up or step down voltage required level, or isolation purpose also we are using the transformer. So rectifier. So which supply are connected? Again here AC supply only, that is connected to this particular rectifier. This rectifier, different type of rectifiers we have. Second one is rectifier. In the case of rectifier, different type of rectifiers we have. Half wave rectifier, full wave rectifier. In that full wave rectifier we have two types. So bridge rectifier and center tap. So we'll discuss these particular rectifiers in the coming videos. But what rectifier is doing? It converts alternating current into direct current, DC current. That's what here the rectifier is doing. So after rectification, you will get the some output voltage of DC, pulsating DC you got. Okay, this is the output voltage you got, pulsating DC. So after this pulsating DC, it is connected to filter. So third one is a filter. What about the filter is doing? So whenever it removes it eliminates ripples present in the source of rectifier. So it is doing that. So it is filter or remove the ripples present in the output of the rectifier. So what you got finally in the filter, some DC value, minimum ripples present in the output of the filter, that is connected to voltage regulator. So what exactly the voltage regulator is doing? So the voltage regulator is doing, it is regulate or the maintain the constant voltage regulator. So it maintain constant voltage, even though even though it change in load, irrespective of load, it maintain constant output voltage. That is the regulators we have. So after that, last one, voltage divider. What exactly the voltage divider is doing here? If your output voltage is available, you want to drive the 3 or 4 loads at a time. So it is possible with help of the voltage divider. So what exactly voltage divider is doing? Voltage is divided and connected to different loads with help of single source. Yes or no? So that means that we can use only one power supply, that regulator power supply. We can connect it to multiple loads. So this is the output. Finally, we have DC output. That output is available to connect the load terminals. So this is about the regulated power supply. All of you got the idea about the regulated power supply. Then we are moving to the steady and pulsating DC voltages. So what we got, steady DC voltages in the output side. This is the time we have the DC. This is the voltage. So this is the DC value. The DC value is a VDC. It is a 0. Okay. This is about the DC, exact DC value. So what about the pulsating DC? Pulsating DC, some DC we have. In that particular DC, the waveform is pulsating above and below the particular DC quantity. This is the ripples we have. Okay, ripples. So how can you find out this particular ripple factor in the circuit? Ripple factor gamma is equal to ripple voltage RMS. Ripple voltage RMS. Okay, that is the AC RMS here, divided by DC voltage. So DC voltage. So in this particular case, this is the DC voltage. This is the ripple factor of AC, this particular circuit. So let us discuss one problem. Based on that, we will get some idea about that. Okay. So here a DC and AC voltmeter were used to measure the output voltage from a filter circuit. Right. So they measure the DC voltage 2 volt. If 2 voltmeters are 25 volt and 2.5 respectively. They provided, first one is a DC voltage VDC is equal to 25 and VAC is equal to 2.5. Both the voltage it is measured. Calculate the ripple factor. Ripple factor is equal to RMS value, that is a VAC divided by VDC. Right. What about the VAC? 2.5. VDC is equal to 25. It is a percentage, right? So into 100. So we'll get ripple factor will be 10%. So what is the answer? Ripple factor is equal to 10%. That is answer. This is the way we are finding out the values of ripple factor. This is about the class related to the regulated power supply. In the next class, we are going to discuss about the filter circuits. Okay, sorry, rectifier circuits. Thank you.